Okay, let's just dive right into this. Welcome to today's Explainer, where we are going to look at something that honestly sounds like pure science fiction, but I promise you it is entirely real. Today, we're exploring physical paradoxes at the very bottom of our oceans that are completely challenging our fundamental understanding of science, biology, and even the origins of life itself. We're venturing into the pitch-black depths to uncover mysterious deep-sea underwater lakes of death and the mind-bending discovery of something scientists are calling dark oxygen. To set the stage here, I want you to ask yourself a seemingly impossible question. How can a lake exist underwater? I mean, think about it. The ocean is already made of water, right? It sounds totally absurd. Yet, at the very bottom of the seafloor, there are actual distinct lakes, complete with their own shorelines, their own waves and beaches. But you definitely wouldn't want to swim here, because these underground beaches are actually graveyards, totally littered with the preserved bodies of sea creatures that just wandered a little too close.
Well, these bizarre anomalies are known as brine pools. Basically, they're ultra-dense, extremely toxic, hypersaline lakes sitting right there on the ocean floor. When a marine animal touches the water of a brine pool, its body instantly goes into extreme shock. Just imagine the visceral reaction of swallowing 5, maybe 10 massive spoonfuls of raw salt all at the exact same time. That instant burning, the extreme dehydration, that is exactly what a fish experiences the second it crosses into this boundary. It is instant lethal shock.
The sheer lethality of what we're looking at is just astounding. This isn't just salty water, we're talking about a highly toxic cocktail. These pools are anywhere from 5 to, in some extreme cases like the Red Sea, 200 times saltier than normal seawater. Plus, they're loaded with hydrogen sulfide and methane gas, laced with toxic metals, and possess absolutely zero oxygen. Because of that extreme salt density, osmosis instantly pulls the water straight out of the cells of any living creature that touches it. It's like a 400-volt electric shock to their system, resulting in instant muscle twitching, organ shutdown, and death. It's a literal death trap. And honestly, here is where it gets incredibly eerie. Once a creature dies, it sinks and settles into the pool. Because the environment has zero oxygen, no scavengers or flesh-eating bacteria can even survive there to decompose the body. Instead, the extreme concentrations of barium and sulfate in the water form a hard crust around the deceased animals. It creates a literal barite coffin. Scientists have actually found the bodies of crabs and other creatures flawlessly preserved for 8 straight years, looking completely untouched, just frozen in time at the bottom of the sea. But these deadly brine pools aren't just fascinating freak occurrences. They are basically natural time machines. If you go back 2.7 billion years ago, Earth looked like an alien planet. Toxic oceans, orange skies filled with methane, and zero oxygen. It really wasn't until about 2.4 billion years ago that cyanobacteria evolved photosynthesis and triggered the Great Oxidation Event, finally flooding the planet with life-giving oxygen. Today, these brine pools perfectly mirror that ancient toxic Earth. They act as natural laboratories for scientists to study how life might have existed long before oxygen ever took over. Which brings us to the dark oxygen twist, a stunning discovery made at 13,000 feet deep. So back in 2013, deep-sea scientist Andrew Sweetman and his team dropped a piece of equipment called a benthic chamber about 13,000 feet down to the pitch-black ocean floor to measure oxygen levels. Now, science has pretty much always accepted one absolute truth. Oxygen is produced up at the surface by plants and algae through photosynthesis, and as you go deeper into the dark ocean, oxygen levels decrease because marine life uses it up. Simple, right? But Sweetman's team found the exact opposite. Down there, in complete and utter darkness, oxygen levels weren't decreasing at all. They were rapidly increasing. They literally found more oxygen at the bottom of the sea than at the surface. They had discovered dark oxygen, and it made absolutely no biological sense. They were so confused, they tested and retested, verifying their equipment over and over, but the data was undeniable. Something down there was manufacturing oxygen without a single ray of sunlight. And the source? It wasn't a plant. It wasn't some mutant microbe. It was rocks. Specifically, these dark, potato-shaped rocks scattered across the ocean floor known as polymetallic nodules. So how exactly does a rock breathe out oxygen? To figure this out, Sweetman teamed up with Dr. Franz Geiger, an absolute master of ocean chemistry. They brought these nodules into the lab, sterilized them to ensure no bacteria were involved whatsoever, and recreated the exact deep-sea conditions. And when they did that, they realized these rocks are literally acting as natural deep-sea batteries. It's wild. The manganese in the rock acts as a positive terminal, just like a battery you'd find in your house. The iron oxide acts as the negative terminal. And that ultra-salty seawater, that acts as the electrolyte fluid. When these all combine, they generate an electrical current strong enough to cause electrolysis, literally splitting the H2O water molecules into hydrogen gas and our mysterious dark oxygen. The really crucial point here is the sheer voltage being generated by nature. When Dr. Geiger attached electrodes to just a single one of these potato-sized rocks, the voltmeter read 0.95 volts. They were expecting tiny, microscopic nanovolts, but nearly a full volt was being produced by one rock. Now, for water electrolysis to occur, you need about 1.23 volts. But since these rocks sit clustered together by the millions on the seafloor, just two of them touching can easily surpass that 1.23 volt threshold. It creates a massive, naturally occurring electrical grid that's constantly pumping dark oxygen into the ocean depths. And that introduces us to the $16 trillion threat, the battle for the Clarion-Clipperton Zone. You see, the Clarion-Clipperton Zone isn't just scientifically fascinating, it's packed with an estimated $16 to $17 trillion worth of minerals. That is, trillion with a T, sparking a massive corporate gold rush for deep-sea mining. But the ecological stakes of this mining rush are staggeringly high. In the CCZ, they're estimated to be between 5,000 to 6,000 distinct species, and incredibly, roughly 90% of them are completely undiscovered and undescribed by science. Virtually all of these unique life forms have evolved over millions of years to rely entirely on this delicate, dark, oxygen-producing ecosystem. And, history gives us a pretty grim warning here. Back in the 1980s, a localized deep-sea mining test was conducted in this area. That single test destroyed 70 to 80% of the life in that specific zone. Now, 45 years later, that ecosystem still has not recovered. The deep sea is an incredibly fragile, interconnected food chain. From a 50-year-old sunken whale carcass providing sustenance for decades, down to chemical-eating bacteria and tube worms, a single disruption can collapse entire biological networks that literally take centuries to build. Now, as you might expect with any multi-trillion-dollar industry, there is significant pushback. The pro-mining lobby, notably a major player called the Metals Company, who actually originally helped fund some of the initial research, they've heavily criticized Sweetman and Geiger's 2024 Nature Geoscience study. They've presented data arguing that the discovery of dark oxygen is flawed and misleading, pointing to potential methodological errors in how the scientists measured the oxygen and hydrogen levels. And some independent researchers have chimed in too, noting that the extreme deep-sea pressures weren't perfectly replicated in the lab, which raises some valid questions about the exact mechanisms at play. So how exactly does the scientific community settle a debate with trillions of dollars on the line? Well, with more rigorous science. To get absolute clarity on this, a massive 3-year study backed by a £2 million grant from Japan's Nippon Foundation is currently underway. Between 2025 and 2028, researchers are sending state-of-the-art equipment over 11,000 meters down. Their goals are strict. They need to consistently reproduce the dark oxygen results, accurately track the hydrogen gas byproducts to absolutely confirm electrolysis, and investigate if deep-sea microbes might actually be playing a supporting role in this whole process. This leads us to our final takeaway, redefining extraterrestrial life, looking beyond the Goldilocks zone. The implications of dark oxygen don't just stay in the ocean, they stretch all the way out into the cosmos. If life-sustaining oxygen can be generated in the pitch black of the ocean floor, it completely redefines our search for extraterrestrial life. For decades, we've believed that life requires a very specific recipe, relying heavily on sunlight. But we're facing a whole new reality. The true cosmic ingredients for life are liquid water, which we already know exists under the frozen crusts of moons like Europa, energy, which can be provided by the heat of hydrothermal vents, and the right chemistry. And with the discovery of dark oxygen, we now know that this crucial chemical ingredient can be manufactured non-biologically, in complete darkness. It acts as a massive evolutionary catalyst for life without a single ray of sunlight. Which leaves us with this final, profound question. Do we even need the sun for life to exist? If the chemical building blocks of life and the very oxygen required to sustain it can be generated by electrified rocks in the lightless depths of our own oceans, who knows what could be thriving in the dark, frozen oceans across our universe? The deep sea is proving over and over that life finds a way, even in the most toxic, impossible paradoxes, like these mysterious underwater lakes. It's a stark reminder of just how much we have left to discover, and just how urgently we need to protect the fragile alien world sitting right here at the bottom of our own planet. Thanks for joining me on this explainer, and keep your curiosity deep.